Fast delivery of high-quality software is challenging, at least from technical perspective. I mean, it's difficult not only for QAs, but also for the whole development team to combine two opposite things. I mean, delivering fast at the same time, keeping it high quality. And as you probably know, the solution for this is automation. I mean, automation can not only save time on repetitive things, like, for example, regression tests that we execute again and again during the development process, but it can also make the feedback faster. So it allows us to shorten the quality feedback loop, to even achieve the continuous feedback. So it allows us to know exactly what's the quality state of the application anytime, whenever it's needed. But the second part of the problem is making this feedback complete. So we'll implement quite a lot of different test types, different tests on different levels. We'll try to increase the coverage. So we will get the feedback that's complete and will allow us to make the decision about the product, if it's ready to release, if it's good enough. But at the same time, the problem is that all of these can increase the complexity. I mean, we'll need to implement all of these different test types, all of these different tests, and it can be time consuming. Then all of these different testing tools that may need to be somehow supported and then maintained. And it's just the beginning. What about infrastructure? What about quality pipelines? Because designing them from scratch can quickly become even more complicated than the test implementation itself. So today, I will show you one of the possible ways of simplifying it with combination of Kubernetes and Testkube. What's Testkube? That's the open source test orchestration and execution framework for Kubernetes. So basically, it allows you to it provides you the test-specific abstraction over Kubernetes. Like, for example, it provides custom resource definitions. So it extends the types that are available in Kubernetes by default with the ones that are test-specific. Like, for example, the smallest possible unit in case of Testkube test. So basically, instructions how to execute specific test, the test suite. So the combination of different tests, the set of tests, the test source. So for example, if you have different tests in the same repository, you can reuse the repository definition. You can reuse authentication settings, for example, in different tests. And it can just simplify things by providing this abstraction. Executor, so that's the test runner's description, how to run this specific test. And also test triggers, so being able to run tests on specific Kubernetes events. Additionally, Testkube provides pre-configured executors, so basically test runners that allow you to execute different test types, like Postman, K8s, Cypress, Playwright, whatever. There's quite a lot of them. Additionally, the one that's, in my opinion, the most powerful one is the custom container executor that can be used to execute any custom image and still use this test-specific abstraction over Kubernetes that Testkube provides. So let's start with setting up Testkube so we'll be able to see some examples. There are some prerequisites like kubectl and Helm, but if you already use Kubernetes, probably you already have this installed. Additionally, you need the Kubernetes cluster. So if you have some test cluster, you can probably reuse it. Testkube supports namespace installation. But if you don't have any cluster yet, you can use Kind or Minikube. That's probably the easiest option to set up the cluster locally and just check how things work. Additionally, you will need to install the Testkube CLI, that's kubeconfig plugin, and also a Testkube cluster side components that will be installed in the cluster. So let's start with creating a Kubernetes cluster request with Kind. That's probably the easiest option, the most stable one at least. So Kind create cluster, optionally the cluster name. Let's name it Testkube Kind cluster, and we can see that it's being installed, it's being created, and the context is set, it's ready to use. Then, assuming the Testkube CLI is already installed, that's just a single binary, it's pretty straightforward to do it. We can use the Testkube install command to install server-side, cluster-side components. Optionally, it's possible to specify the namespace if you want to use the different one that defaults Testkube. You should check if the context is configured correctly, and you can confirm it will be installed. So then we can check what's installed there, kube control get deployments, namespace testkube, and we can see, for example, dashboard. That's Testkube's web UI that can be used to manage the test, execute them, check the results, and just check things that are easier to visualize in the graphical way. There is also API server, that's the work orchestrator that handles executions, gather results, and saves them, process, etc. And there's also the operator, which watches Testkube custom resources, handles changes, communicates with API server, etc. So if it's ready, then let's create some tests. First, let's create a test with the Testkube CLI, because that's probably the easiest option if we already have the CLI. We can use the Testkube create command. It allows us to create different Testkube resources, like, for example, test in this case. And let's start with creating a K6 performance test. Let's assume we already have it created in the repository, and let's run it with Testkube. So let's name this test K6 example. Then we need to specify the type. In this case, that's K6 script, because we just need to tell the Testkube's executor which of them should be used, what's the test type. Then the test source, so how should it get this test? In this case, we'll use the Git repository because the test is already placed there. So we need to specify different Git settings like QRI, that's the main Testkube repo. It's open source, so you can check it there if you want. The branch main, the default one, and also the path to the test with the Git path. In this case, it's just a single dash file that will be executed. Hit enter, it's created, and we can now run it, or optionally we can check what's there. So we can use the Testkube get test command and then the test name to get some test details. Like we can see what's the name. We can see that additionally there are some labels that were created. It's just simple to make some things with the labels. That's why some of them are pre-created. It's possible to filter the test, for example. And also there are different repository settings. So let's run this test. Testkube run test, K6 example, and -f is an optional option to follow the execution. So the result will be returned directly after the command is executed. It won't be executed in the background instead. The test is executed, everything is fine. The execution is successful. So what's also possible with this CLI? Well, it's possible to manage the resources, all of them. I mean, it's possible to create, edit, and delete them. And which kind of resources? Like, for example, the test that I just showed. Also the test suite, test source, and executor. So basically, it's possible to manage all of these in the more convenient form. Additionally, it's possible to manage the executions, like running them, watching them, and also aborting if needed, both tests and test suites. Additionally, it's possible to download artifacts and manage the Testkube. We already used Testkube install a while ago, so it allows you to install the cluster-side components. It's also possible to upgrade it this way. But additionally, it provides also the Testkube dashboard command that handles port forwarding in the easy way. So it's not needed to set up any ingress or use any other method to access the web UI. It will allow you to run it locally. So that's how the dashboard looks like. It allows you to view different tests, check the execution, check logs, and manage everything. I mean, adding tests, removing them, editing test suites, executors, triggers, test sources, etc. Let's create the second test with this UI. In this case, we'll use the Postman example. So in this case, we have the file locally, not in the repository, or at least we have it additionally locally. We'll upload the local file. That's why the source file is used here. Let's set the name to example Postman test, the type Postman collection, test source file. It's possible to select it here, and then create the test will be created. It's possible to execute it both with dashboard and with CLI. But the third, and in my opinion, the most powerful method of managing tests is through CRDs, because it's just the Kubernetes-native way of handling things. So let's start with the test CRD. In case of test CRDs, it's possible to describe everything as a YAML file, or this in the case of any of these CRDs. So we have the dedicated kind test type, which can be used, which extends the default ones available in the case of Kubernetes. And it provides the test specific abstraction here. So we have the metadata. In this case, we'll run the Cypress test that's again in the repository. So let's name it Cypress test example. We need to specify the namespace in the metadata. So that's where Testkube is installed. And optionally, we can set labels. So we'll be able to filter this test in a convenient way. So in this case, we'll set the label type end-to-end. So we'll know which test type is it. It's the end-to-end test. Then we have the spec. So the test type again, in this case, is Cypress/test. And the content, so the source from we will get to this test. In this case, we use the Git repository. So we have different repository settings here. The URI, so that's again the Testkube repo. You can check this test there. The branch main, the path, that's the path to the Cypress 12 project inside this repo that will be executed. And because this test is not just an example, it's also internally for testing Testkube, there are some things that are additionally checked here. So this test, for example, checks if and variables and arguments are set correctly. So we can set both variables and arguments for any test using execution requests. So we have variables there. That's how we can set the env. Like, for example, this Cypress custom env with Cypress custom env value. And also we can set arguments here that will be passed directly to the Cypress binary that will be run there. There is additional config parameter video false. So we won't record the video during the test execution, just to save some resources. And if we have this definition saved into the YAML file, then we can use the Kubernetes-native method. So we can just use kubectl apply -f and the name of the YAML file, and it will be applied in exactly the same way as you'd apply any standard Kubernetes resource. Additionally, to make the generation of these YAML files simpler, Testkube provides the CRD-only option. So you can use Testkube create for any of the available resources like test or test suite or executor or anything else. And you can add the CRD-only option to the CLI. And instead of creating this resource, the Testkube CLI will generate the definition that you can later use to manage this test in the repository, for example. Then the next possible executor, the one I mentioned earlier, that in my opinion is the most powerful one, is custom container executor. So basically, it allows you to execute any custom image and use this test-specific abstraction. So it's another test, that's another resource type that Testkube provides, kind executor. So we can define first metadata name, that's the name of the container executor. In this case, would like to run the Cypress project, but we need a very specific version 12.7, for example. So let's name it this way, container executor Cypress 12.7. Then the spec part. So that's where we have to define the image that will be used. In this case, we'll use the official Cypress image named Cypress included 12.7 because that's the exact version that we need. And we should also specify the executor type, so it will be the container executor. Then the types keyword, that's where we need to set the test type that will be then available for tests. So like, for example, we used the Postman collection before, or we used another test types for K6, etc. So that's the test type that will be available for the test. Then we have the test definition. So the only thing that's different here is this type. So instead of using Cypress/project, we'll use this custom type that we just created. And again, kubectl apply. You can apply all of these definitions this way. You can store everything in a repository in a convenient way. But what about pipelines? How to build pipelines using Testkube? Well, there is a lot of possible ways of handling the test trigger and etc. So let's start maybe with the trigger method first. We can trigger tests manually, like we did with CLI, with Testkube run, or with dashboard. It's also possible to cron trigger the test, so they will run at specific time or every few hours or every 3 minutes or whatever is needed there. We can also trigger a test from the standard pipelines that are already used. Like, for example, if you use GitHub Actions or any other CI/CD tool or pipelines, you can trigger the test directly from there using CLI or native actions, like, for example, in the case of GitHub Actions. Or as long as you have access to the cluster, you can trigger them there directly. But there is one more thing that make it not required to even have any kind of external pipelines. The cluster event. So it allows you to trigger tests on Kubernetes cluster events. So it's possible to build pipelines completely inside the Kubernetes cluster with Kubernetes and Testkube. So let's create a trigger first. Let's assume we would like to run the K6 example test when the Nginx deployment is created in the default namespace. So we can use the test trigger type to do it. So that's kind test trigger again. Name, let's make it as descriptive as possible. So trigger a K6 example on Nginx creation. So we'll trigger this test when this Nginx deployment will be created. Then the spec resource that will trigger this action, resource type deployment, resource selector. So that's the way of selecting the specific resource that should trigger the action. So in this case, we'll identify it by the name, Nginx, and the namespace default. So Nginx deployment in the default namespace. Then when the action should happen, event that will trigger some action. So event created in this case. So when this deployment will be created, it will trigger some action. I just use the created type here because it's easier to show example this way, but usually you will use the modified type here. So if the deployment would be modified, for example, if the new version will be released, it will trigger some action. And what's this action? In this case, it's the execution of test, and action that will be triggered is running this test. So basically, it will run the test on action. Test selected by test selector, in this case by name, K6 example, and the test would be in the Testkube namespace because that's the one where the Testkube is actually installed. So let's execute this action. Let's create this Nginx deployment. So we'll see what will happen there. Kube create deployment Nginx with the image Nginx. And we can see deployment Nginx has been created. And that's exactly the moment where this test will be triggered. So let's display the test execution details. We can see that this test has been executed, it even passed, and we can see the test type is test trigger. So that's the event, that's the type of the test execution, how it was triggered, not manually, but with this specific test trigger that happened on action. But triggering based on names and triggering test based on names is not the only option. It's possible to mix both name and labels in any way. So for example, it's possible to have multiple tests with label, like different Cypress tests, different end-to-end tests, or different set of tests that you would like to execute on specific action. So for example, if you will deploy Nginx, you would like to execute every single test with specific label. Or from the other side, you might have multiple resources with specific label, and if any of them will be created or any of them will change, it will trigger specific test. So it's possible to combine them and build pipelines based on specific resources. So for example, a specific deployment of specific pod would be updated or deleted or created. It can trigger actions, it can execute specific tests that will confirm if the action is successful. So basically, all of these CRDs can be considered as GitOps compatible way of test management. I mean, it's possible to put all of these into the repository and manage them in a really convenient way. And in the end, just one more thing, how the project structure look like in the case of Testkube's repository, because we use Testkube for testing itself. So we have the test directory where we have all of possible test executors like artillery, Cypress, JMeter, K6, etc. We have the specific tests or projects. For example, in the case of Cypress, we even have 5 different Cypress versions, at least projects. Then in every single of this directory, we have another directory named CRD, where we have test definitions. So not only we have the tests in the repository, but also we have CRDs that describe the way how to execute them, that can be used, that can be applied with kubectl. And it's not only about the tests, we also have the test suites, executor, and triggers. Everything is in this repository. Everything can be easily applied and managed there. And then, if you'd like to see some more examples, I recommend you to go to the Testkube docs, Testkube.io, or you can check the GitHub, because it's open source project. Everything is this repository. You can check everything there. And there is quite a lot of test examples in the test directory, along with different definitions, different CRDs for testing different use cases, different edge cases, and everything that may be needed there. So that would be all. I hope you enjoyed the presentation, and thanks. It was great to be here today.